Okay, this is the demo of 5P. So this is the initial startup. If there's a command line argument that loads a particular file definition, puzzle definition, it defaults to this one, which is a particularly easy one that has no backup. So it's a very good one to start your tests with. It will test part of your program, but of course, as soon as your program works on this, then you need to go to one of the other 5 tests that I've put in the startup package. So there are the game I talked about in class. Here I've set up a couple of extra buttons that as we're playing the game, so solve says solve the puzzle, and it goes through and places numbers in open positions in order. There's a delay in placing it that is controlled by this slider here, and this button show toggle button says you want to see this, you want to see this happen. This is a good thing to watch to see that you're proceeding as you might expect in your placement and ordering of things. As I said, this is a particularly simple puzzle. I arranged it so it had no backup. So it just goes through, and every time it fills a number, it gets it right. Not necessarily the first one, but I guess actually it is the first one. It doesn't fail, and it never has to back up. So it is finished. Now we can use a file browser, which there's some support in. I've made a new version of CS416.run that, sorry, CS416.jar that has a new package and a new file in it called utilities. Utilities allows you to open this J file chooser to pick another file to test. So we pick that. We're now going to test file 1. Try to solve file 1. File 1 has backup. I'm going to make it faster so it doesn't go quite so slowly. I'm still going to show each move that's made when we solve the problem. And here you see some backup already, then it goes a ways forward, and then it backs up a little bit, and backs up some more, and so this is, notice that the colors that start the numbers that start the puzzle are always black, and then the ones that are put in by the program are red. Doesn't matter whether it's black and red, they have to be 2 different colors so that we can show it up. Once you've run it once, you could run it again, more slowly maybe, the same puzzle. If you thought maybe something was wrong or it wasn't working quite right, you can run it more slowly. You cannot change the speed while it's running. This is when you run your program, it's a recursive solution, and it just keeps running. It never gets to a point where it gives the Java environment a chance to do any interaction. And it's actually being called by an interrupt handler, an event handler. And Java doesn't do any interaction until that event handler returns. So we can't change the speed while it's running. If you're running in Dr. Java, you can kill it. If you're running on a terminal line, you can kill it if it's just taking too long. And it can get pretty slow. You can turn off the showing every move, and when you do that, the solution is so fast you don't even see it. Let me load a new one. So here I've got the show means show every move. Here I just say solve it, and it fills in the time it takes to fill in is more a matter of the graphics. It's also possible to just show show a few means show every 1,000 moves. There's one solution here, one data set I have, test 5, that does some 70,000 changes. So you don't want to have much of a delay, and you only want to show a few of them. Again, it's one every 1,000. So we solve that. Oh, that's pretty fast. Anyway, okay, now there's one other set of requirements for the program, and that's that you need to produce some output in a very special format, and that's shown in here. You should not print anything to system.out except the lines of a set of lines of code. You can't see on here in Dr. Java. You could see this is all system.error. This is system.out. For each file that you run, you need to print to system.out the name of the file, the solution in exactly 9 lines with exactly 1 space preceding each number, and then the line after that, these last 2 numbers. This first one is the number of recursions that you did in order to make this solution, and the second one is the number of backups that occurred where you completely failed to fill a number and had to back up and replace it. Those should be fairly easy things to find where you start counting those in your solution program. This is the one that takes, these represent about 60+ thousand actual changes of numbers. We're doing this because we're going to grade, some of our grading will be to run your programs and actually just compare our output with yours by a program that will do it. So the only thing that you should write to system.out are these 3 components: the name of the file, the solution with exactly 1 space between the numbers, and these 2 numbers, the number of recursions and the number of backups. I think that's it.